Okay, so you've set it up on your computer. We actually haven't even evaluated it yet, but you have your function, which is 1 plus x over 3 minus x squared over 9.
Yep.
We did set it up for the convergence for 50 to the 1/3, so we can see what the continued fraction terms look like. And then we have 3 times 23 over 27. So, okay, go ahead and evaluate this.
All right. So we get...
Oh, this is in a separate thing, so you got to evaluate that first.
Let's see.
Okay, and then evaluate again down there. All right, so there we go. So it looks like the from the continued fraction, we do get some interesting approximations. And from our approximation, we get 7895 over 2187. So we got to figure out if that's close to cube root of 50 or not.
Okay. So I think down here we can do that.
Yeah.
So is there a function for cube root? I can just do power.
Yeah, do power 50 to the 1/3, or you could actually just type 50 to the 1/3. Either way, and then you want, say, 10 decimals there.
Okay, so then we can do maybe our 7895 divided by 2187, and then the third term of our continued fraction sequence to compare. So that's 11/3.
Okay.
Okay, so we got square root of, or cube
Scroll it up a little bit. Let's make sure we're on screen. Okay, so
cube root of 50.
we got 3.60 for our approximation. So that's actually not very good. So we might have made a mistake. So let's go back up and make sure we got
1 plus...
Oh, yeah, we did make a mistake. It's not 23 over 27 when we factor out. I know about this mistake because I made it myself when I was playing around with this morning. When we factored out on the last thing, and we'll show it in the next video because we're going to continue, we actually get no, we do get 23 over 27, my fault. 23 over 27, 1 plus x over 3 minus x squared over 9.
Maybe it's just not a good approximation yet.
Maybe it's not. Okay, yeah. Maybe it's not. Okay. Well, scroll up all the way. Put this up. Okay, so we got 3.60997. 11/3 was actually better.
Yep.
And that, so maybe you're right. Maybe it's just not yet a good approximation. Okay. Go back up to the continued fraction. I hope we haven't made a mistake here, but that's fine. But 27 is kind of far away from 50, so maybe we needed more terms or something. Can you think of a new, rather than using 3 or 4, what we might use for an approximation to 50 to the 1/3, and then we could, once we have a decent approximation to 50 to the 1/3, we could come back to this. So what's another number that we could use as a decent approximation to 50 to the 1/3?
50 to the 1/3. I mean, sort of. It's going to be between 3 and 4.
Yep, that's right. Can you think of some other things that maybe are better approximations than 3 or 4?
To the 1/3. It'll be maybe around 3.5 actually, because it's
yeah, but we can even do better. We know we actually know some numbers that are going to be good approximations to 50 to the 1/3.
Yeah. I mean, we have some here. Yeah.
Yeah.
It's 11/3, 70 19th, 1061 over 288. I guess.
Okay, so what would you, of those numbers, what should we try to use to do our approximation?
70 over 19 seems Fine.
Okay, 70 over 19. All right, so we'll go back to the whiteboard, and we'll use 70 over 19 as a better approximation to cube root of 50 than 3. And we'll see what kind of approximation we get with just our 3-term power series now. All right?
All right.